Welcome to The Explainer. Today, we're going to dig into a fundamental truth about AI, one that, honestly, it changes everything. And it's this: bad data will always defeat the best model.
So let's kick things off with a pretty provocative question. We hear so much about bigger, better, faster AI models. But what if? What if the model isn't the real reason that most AI projects fail?
Nope, it's not the super complex, fancy architecture.
And it's not some genius, groundbreaking algorithm either.
The real culprit, the thing that secretly torpedoes so many AI projects, it's the data. You could have the most advanced, most brilliant AI model on the planet, but it becomes completely useless if the data you feed it is garbage. Okay, so to really get our heads around this, let's use a simple analogy. Think about cooking.
Imagine your super sophisticated AI model is a world-class chef, right? They've got all the skills, all the fancy techniques down pat. But the data, well, the data is the ingredients. And we all know what happens next, don't we? No matter how amazing that chef is, if you give them spoiled, rotten ingredients, you're not getting a gourmet meal. You're getting a disaster.
And listen, this isn't just some cute analogy. It's a major shift happening in the industry. The legendary AI pioneer Andrew Ng basically said it himself. Focusing only on the model is hitting a wall. He argues it's way more efficient, you get more bang for your buck, by focusing on engineering the data instead of just tweaking the model over and over again.
And here's the absolute key to understanding this. Modern AI doesn't discover truth. It doesn't think like we do. What it does, and it does it incredibly well, is absorb patterns from data. So, if those patterns are biased, or incomplete, or just flat out wrong, the AI will learn those flaws perfectly, and then serve them right back to you, looking completely confident while doing it. So, if data is this important, how do the pros handle it? How do they avoid these disasters? Well, it really comes down to a kind of playbook with two main strategies: structuring your data the right way, and then making that data even better.
Okay, first rule of the playbook. You never, ever train on all your data at once. You split it up. Think of it like studying for a big test. The training data is your textbook. It's where the model does all its learning. The validation data is like the practice quizzes you take along the way. You use it to tune your approach to make sure you're not just memorizing answers. And the test data? That's the final exam. It's completely new, and it's the only true measure of what your model has actually learned. Now, data also comes in two basic flavors. You've got labeled data. This is the good stuff. It has the answers included. So you have a picture of a cat, and it comes with a label that says cat. Super powerful for teaching an AI, but man, is it expensive and slow to create. Then you have unlabeled data. This is basically everything else. All the text, all the images on the internet without any tags. It's cheap, there's tons of it, but it's a lot harder for the AI to learn from because it has to find the patterns all by itself.
And this brings up a really crucial, kind of creative step that most people don't think about. See, an AI doesn't see reality the way we do. It only sees what we choose to show it. That process is called feature engineering. It's the art and science of deciding which variables, which pieces of information are actually important for the model to see. Honestly, making a smart choice here can be way more powerful than picking the fanciest model.
So what happens if you just don't have enough data to begin with? Well, you can kind of make more. It's a neat trick called data augmentation. You take the data you have and you create slight variations. You might flip an image horizontally, change the brightness a little, or add a tiny bit of random noise. This teaches the model to be more flexible and helps it recognize things out in the messy, unpredictable real world.
Okay, but even if you do everything right, there are these silent killers. Subtle mistakes that can creep in and completely sabotage your entire project, making your model look like a genius in the lab, only for it to fail miserably in the real world.
And probably the most insidious of these is something called data leakage. This is basically when your model gets a cheat sheet. It's when information from the future or from the test set accidentally leaks into the training data. So the model looks like it's performing brilliantly, but it's not learning. It's just cheating. It's like a student who got a copy of the final exam answers beforehand. Sure, they'll get an A+, but they didn't learn a thing.
Let me give you a classic textbook example of how this happens. It's super common to scale your data so all the numbers are in a similar range. The wrong way to do this is to scale the entire data set and then split it into training and testing sets. Why is that so bad? Because now your training data has been influenced by the test data. It's seen the future. The right way is to split the data first, then figure out your scaling rules using only the training set and apply those same rules to the other sets. That keeps everything clean and prevents the model from cheating.
So, when you pull all of this together, what's the big lesson here? It really forces us to think about what AI actually is.
Here it is. AI does not think. It reflects. It's a mirror, a powerful, high-fidelity mirror that shows us exactly what we put into it. All the patterns, all the biases, all the hidden flaws in our data. The old saying, garbage in, garbage out, has never, ever been more true than it is in AI.
And that is why the truly great AI systems aren't just built with clever algorithms. No, they are built on a foundation of disciplined, meticulous, even obsessive data practices. The best teams know that a real breakthrough is more likely to come from painstakingly cleaning their data than from just grabbing the hottest new model off the shelf. So let's leave it with this thought. We often hear that data is the fuel for AI, but that's not quite right. It's so much more than that. It's not just powering the machine, it's steering it, it's setting the course. The future of this technology isn't going to be decided by who builds the biggest model. It'll be decided by who understands their data the deepest. Because in AI, data isn't just fuel. Data is destiny.